Okay guys, so if you don't already know, trigonometry means the study of triangles. So we're going to start getting into more of chapter 4 by reviewing right triangles from that stuff you learned in geometry and probably algebra 2, and then starting to talk about sine, cosine, and tangent. So we have a right triangle here because it has a box in the corner. So typically we label the corners of the triangle with capital letters, and then we have their opposite sides. So one thing to remember from geometry is the Pythagorean Theorem, which is going to become very useful for us. So remember, that tells us that the sides squared and added together equals the square of the hypotenuse. So a squared plus b squared equals c squared. Okay, so what trigonometry does, at least in right triangles, it relates the sides together. So a lot of the times we'll use this symbol theta, which stands for an angle measurement. So you're going to see that symbol a lot. You might see other symbols as well. So the sine is abbreviated SIN of theta is equal to the opposite side divided by the hypotenuse. We'll go ahead and label the sides of our triangle. So the hypotenuse is always across from the right angle. So here's our hypotenuse opposite. So you start at the angle and go all the way across. So this side would be opposite of that angle theta. And then we have the adjacent side, the side right next to the angle. Cosine, so hopefully this is all familiar. Cosine of theta is equal to the adjacent side over the hypotenuse. And then tangent of theta is equal to sine of theta divided by cosine of theta, which is the same thing as saying the opposite side divided by the adjacent side. So we're going to do some examples and see how those things work. So you have a right triangle on the screen, and it's a typical 3, 4, 5 Pythagorean triple triangle, so you probably worked with that a lot in geometry. We want to find all three trig ratios for angle A. So if we're starting at angle A, we want to first know what our hypotenuse is. So across from the right angle is the 5, so I'm going to label that side as H. Opposite of A, you go across the triangle, so the 3 is opposite and the 4 is right next to it, so that's our adjacent. So the sine of angle A would equal opposite, which is 3, over the hypotenuse of 5. Cosine of angle A would equal the adjacent 4 over the hypotenuse of 5. And then tangent of angle A is equal to opposite, which is 3, divided by the adjacent, which is 4. So there are our three trig ratios for that triangle, for that specific angle. So now, what happens if you're not given all of the sides? So we want to find all three trig ratios again for angle A, but we're missing a side. So if we look, we have the hypotenuse is 8, we have our opposite, which is 6, but we're missing our adjacent side. So that's when we want to go back to our Pythagorean theorem. So we know that 6 squared plus our adjacent side squared should equal 8 squared. So we want to solve for A. So 6 squared is 36. 8 squared is 64. So we're going to subtract 36 from both sides. So if we subtract 14 minus 6 is 8. 5 minus 3 is 2. So we get a squared equals 28. So to get a by itself, we have to take the square root. Now, hopefully in Algebra 2 you learned how to simplify square roots. So you want to do that by breaking 28 into numbers that multiply to 28 where there's perfect squares. So I know that 28 is the same thing as 4 times 7. So you can break apart the square root. And then the square root of 4 is just equal to 2. So we really have this is this 2 square root of 7. So now we can label this side and go ahead and do all of our trig. So we have the sine of angle A is equal to 6 over 8. And we always want to reduce our fractions, so that's going to leave us with 3 over 4. We have the cosine of angle A is the adjacent, which we just found to be 2 root 7, divided the hypotenuse of 8. So we can divide both top and bottom by 2, so we get the square root of 7 divided by 4. And then the tangent of angle A is equal to, not 2 root 7, whoops, that's the adjacent side, gotta put opposite on top. So that would be 6 over 2 root 7. Divide both top and bottom by 2, we get 3 over the square root of 7. Now, we always want to leave our fractions simplified, and you can't leave a square root in the denominator because it's not very simplified. So we're going to call this process rationalizing, and it's getting the square root out of the denominator of a fraction. So to do that, you have to multiply the top and bottom of the fraction by something that would cancel with the square root of 7. Well, if I multiply square root of 7 by another square root of 7, it should go away. So the square root of 7 times the square root of 7 would be the square root of 49, or a regular 7. And then on the top, we get 3 root 7. So that would be our answer for tangent. So there you go. There was a little fast review for you on sine, cosine, and tangent. So stuff that you should have covered in Algebra 2 and geometry.